Hi guys. So today, and actually this whole week, we're really going to switch the focus to solving equations. We're going to look at both log and exponential equations. Now I know we did exponential stuff earlier, but we wanted to wait until we learned logs to actually solve exponential equations because you'll need logs for them. But that's what we're going to do on Thursday. So today we're just going to look at how to solve log equations. Now typically log equations come in two forms. You either have a log equal to another log, or you have a log equal to a number, and depending on the format you have is the way you need to solve it. Now, typically though, no matter what kind of log you have, a really good strategy is to use your properties for condensing those logs together. So on this first one, I know those two logs on the right can be rewritten in a different form. So what I can do first is I can move 2 to be the exponent. So that would become 4 squared. And I also know if I have two logs that are subtracted, I can divide the arguments. Well, then at this point, if you have two logs with the same base that are equal to each other, then at that point, all you need to do is set the arguments equal to each other. Now, that's the only way that these will be equivalent. So at this point, x minus 4 is equal to 8, and I get that x equals 12. Now, just like it was with every other equation we've done so far this year, you need to make sure you check for extraneous solutions. Particularly any solution that gives you a negative argument. Those will be your extraneous solutions. All right, now let's look at this next one. This one's a little bit different because as you'll notice, it's not a log equal to another log. Okay, there's just a single log and a bunch of other things. So what I'm going to do is I'm going to get this log by itself. So I'm going to start by adding 7. Dividing by 2. And now at this point, because it's not a log equal to another log, I can't just set the arguments equal. I cannot just do 2x minus 1 equals 11 over 2. That's not true. But what I do know is I can rewrite this in exponential form. So natural log has a base of e, so e to the 11/2 power is equal to 2x minus 1. Well, then at this point, to solve for x, I can add 1 and divide everything by 2. Now, it's not a very pretty answer, but if you want the exact answer, you could just plug this into a calculator to get it. All right, so again, let's just look at 2 more here. Again, if you can use those properties to condense, use those properties to condense. If you have a log equal to a log, you can just set those arguments equal. So looking at this first one, I can combine those two logs together on the left by multiplying those arguments. So this would become the log of x plus 2 times x minus 1 equals 1. Well, let me go ahead and FOIL that out just so it looks a little prettier. This would be x squared plus x minus 2. Well, now I can write this in exponential form. So there's no base listed, so that base is 10. 10 to the first is equal to x squared plus x minus 2. Well, it's quadratic, so I need to set it equal to 0. So x squared plus x minus 12 equals 0. Then I can factor, and I get 2 possible answers. Only problem is here, negative 4 doesn't actually work. If I plugged in negative 4, actually in both places, it only needs to be true for one of them, but if I plug in negative 4 here, that's the log of negative 2. I can't take log of negative 2. You cannot have a negative argument for your log. So that's not possible. So your only solution here actually is 3. All right, then let's look at example 4. There's actually 2 different ways you could work this out. I'll go ahead and do what I think might be easier for most of you guys. I'm going to move this log to the other side so that all my logs are together. Well, if you're subtracting logs, you can divide the arguments. So I can rewrite this as log base 2, x minus 3 over 3x plus 1. Now I can rewrite it in exponential form, so 2 to the third, so 8. And then I can just solve this rational function. So a rational equation. So I can cross multiply or multiply both sides by 3x plus 1. I get x minus 3 equals 24x plus 8. Don't really have a lot of space here, sorry about that. That would give me a negative 23x is equal to 11. So x is equal to a negative 11 over 23. Now the other way that you could work this out, I'll go ahead and put that at the top, and I'll erase that box. I don't know why I made that take up half the slide. Sorry about that, guys. All right, so another thing that I could do here is I can actually rewrite the number 3 with the same base. So these are both log base 2. Well, if I want all of these to have log base 2, I can rewrite 3 as log base 2 of 8. Because that is 3. If I were to evaluate that, 2 to the something power is 8. 2 to the third power is 8. So that is equivalent. So I can rewrite this expression. And now I can solve this equation. So I can combine the 2 on the right by multiplying. And now I have a log equal to a log. So I have x minus 3 equals 24x plus 8, which is probably going to look pretty familiar to you guys because that's the same thing that we had down here. Solve that and you still end up with the same answer. X equals negative 11 over 23. All right, now I was so hurried to try and get you guys to see the extra method of doing this, I forgot to do the very last step, which is check to see if your answer is extraneous. If I plug in negative 11 over 23, negative 11 over 23 minus 3 is a negative number. I can't take the log of a negative number, so this is an extraneous solution. So the only solution that we found is extraneous, which means this actually has no solution. So no matter which way you choose to work it out, you're going to end up with no solution. All right, so again, today, like I said, we're just going to focus on log equations. You'll really kind of see these two forms. A good step, if you can condense any logs, condense them. If you just have a log equal to a log, you can just solve the arguments. Otherwise, rewrite it in exponential form. So for today, again, pretty similar. You got your practice problems, and then you'll have that week 6 assessment. It is going to have those exponential equations on there as well. If you have questions, you can fill out the video request, email me, or jump in that Zoom session.